Hello. Before we begin, I want everyone to take a second to look at the objects around them, maybe the colorful clothing you're wearing, your phone case, something like that. And you'll see that we have many colorful objects that truly bring our world to life. However, all of these colorful materials are actually hiding a dark truth. And that's that the dyes and pigments that we use to color plastics and polymer-based textiles pose a huge environmental challenge. Nearly 20% of all global industrial wastewater is attributed to textile dyeing, and these carcinogenic compounds that we use as dyes can leach into water and be highly pollutive to the water around dye houses. Moreover, even though colorants are only a tiny percentage of really minority component in plastics, they can alter the rate of biodegradation, they can hinder our recycling practices, and they can change the rate of microplastic formation. So all of this begs the question, how can we produce colorful materials without these harmful environmental impacts? Now, nature has an answer, like it does to many questions, and if you think about peacock feathers and butterfly wings and other bright, colorful natural materials, they actually have these reflective colors that are known as structural colors, as opposed to absorption-based pigments and dyes. And so what I do is I make cellulose-based materials that also have reflective structural colors. In the center of my screen, you can see some examples of these samples, and what I do is I take ethyl cellulose, a chemically modified form of cellulose, and I dissolve it in acrylic acid, and then I polymerize that to make it solid so that we have ethyl cellulose and polyacrylic acid. Those are the only two components, but I can get a wide variety of visual appearances, different colors, matte versus iridescent, and even spatially programmed patterns. And these materials have really similar mechanical properties to plastics. If you pick it up, it feels like your commodity plastic, but you can actually chemically separate these two components, and that's all that there is to them. As a polymer scientist, though, I feel that if we're going to replace commodity plastics, we need to replace them with something that offers additional functionality. We can't just sort of make a new version of polyethylene, because that won't be industrialist scalable. And so I actually do a lot of work to think about how these cellulose-based materials can be used as colorimetric sensors. So those same materials that are seen in the center of my slide are actually water responsive and change their color in response to different swelling conditions. And I've also been working on a project where we attach photo switches so we can make light-responsive, structurally colored materials. And I'm currently working on actually developing materials where we have electrochemical activity as well. The overall idea is we can take these materials as alternative plastics, and we can not only replace plastics, but we can sense environmental conditions around the places where we produce these materials and sort of get a two-in-one benefit. Thank you.